My last video was pretty heavily focused on Odin and why I view it as the perfect C alternative for modern software. One type of comment that I received quite a lot was about Zig, which I didn't mention in the video. I think Zig is a fine language, but I wouldn't call it simple, nor would I say it's all that C-like, so in this video I'm just going to compare why I prefer Odin over Zig and why I didn't mention it in my last video. One of the first things I mentioned about Odin is that it's not trying to adhere to any principles just for the sake of it, and would rather be a useful language over a correct one. This, alongside trying to still feel like C, is why I prefer it over Zig. While Zig is certainly somewhat C-like, a lot of its features cause you to write code that looks different than the C equivalent. One example of this is methods, a feature that Odin explicitly doesn't have because it steers the code in a slightly weird direction. When your data has behavior, you're much more tempted to think of every individual object as its own unit, rather than as part of a larger group, which is the model that works best with simpler approaches like arena allocators. This is a huge problem in C++, where people use things like smart pointers to manage every independent allocation automatically, rather than grouping them together semantically. In practice, people use arenas all the time in Zig, but it's a case where translating between C and Zig is more likely to require a restructure than it is with Odin. On the topic of arenas, allocators are where a lot of my complaints with Zig come from. Both Odin and Zig have good, first-class concepts of allocators, including a large standard library that explicitly uses them. The main difference comes from how much you're required to think about them. If you want to use allocators explicitly, that's fine, and the process is similar in both languages. But the majority of the time, I simply want to use a heap allocator. I think Zig's new juicy main is one way of getting a default allocator, but you still have to explicitly pass it everywhere. I see the benefit of this. You can tell where allocations happen at a glance, but in practice, I don't find it to be all that important. I much prefer Odin's approach to defaulting to whatever's in context, allowing you to specify whenever you want to. Even still, Odin does have a file tag that disables every allocator parameter with a default value, forcing you to properly pass through allocators in most cases, and I'm fine with that. Plenty of people like to code that way, and it doesn't bother me. One place where Zig really does bother me, though, is the behavior of things like standard array lists. The behavior of the collections in the Zig standard library is to always accept an allocator for every operation, even though that rarely makes sense. Again, I get the idea. Appending can cause an allocation, so an allocator is passed, ensuring the caller always knows where an allocation could happen. In practice, though, this feels like something I mentioned in my last video, adhering to principles over being actually useful. There aren't really any cases where it makes sense to append with a different allocator than you used previously. It's just a place for bugs to sneak in, and it adds friction to code where it isn't really needed. In Odin, collections like maps and dynamic arrays keep track of their allocator, meaning you can set it explicitly, but you can't accidentally change allocators without realizing. Zig's approach makes it a lot easier and removes safety information which would have been trivial to keep. In Odin, you can pretty much assume any procedure that accepts a dynamic array will allocate, purely because they accept a dynamic array. If a proc wasn't going to allocate, it would accept a slice, since slicing a dynamic array is effectively a free operation in Odin. It seems to me like Zig prioritizes explicitness over being actually useful in any way, to the extent that it would rather introduce bugs and make code more complicated just to make it that little bit more explicit. Another reason I dislike Zig, this one more concrete, is that the errors just suck. Zig uses a special type to represent errors, which really confuses me. One benefit I've read about it is that it allows the compiler to automatically recognize hot versus cold paths by assuming errors are unlikely, but that's negligible in most cases. Zig's error handling could have been great. The implementations of try, catch, and or else are great concepts, but the fact that they only work for special error types puts you in an awkward middle ground between basic and advanced error handling. Requiring a special type of enum means that if you just wanted to return a basic bool to represent whether the operation failed or not, you're instead forced to make a whole enum for it. Meanwhile, if you wanted to return some real meaningful info, you're instead forced to add a parameter to your function that you fill out on error. Odin handles this in a much nicer way. It has a few special error handling operators, just like Zig. Odin's error handling operators are or return, or continue, or break, and or else. But they don't just work on special types. Instead, they work on the same regular types that you'd already use for errors, including booleans, enums, and unions. They even work on pointers if you want to do something like Go, where you have a generic error interface, but that's not a pattern I've seen before. Odin also doesn't have an equivalent to Zig's catch, because it's not useful. The basic cases where you just want a default value are handled by or else, but if you wanted to just run code if the code had an error, we have a tool for that. It's called if statements, and they've been around for 3/4 of a century. I do know some people complain about the constant if error does not equal nil checks in code, and I agree it's ugly and unnecessary when all you want is basic propagation or default values. But when you do need proper handling, it's hard to get more pragmatic than just checking it directly. Zig also has an error defer keyword for code that you only run when a scope exits with an error. You could argue that this is the best reason to have errors as special types, but Odin takes a simpler approach that does basically the same thing. You can just defer an if statement that checks the error and runs code there. I can see why someone might think that that's ugly, and it does require to use named return values, but I still find it to be a really simple approach that cleanly states exactly what the code is doing, rather than relying on the language to tell you what an error is. I really like the idea behind comp time. In fact, I might even call the concept of arbitrary compile time execution something significantly better than what Odin does, which is basically implement compiler intrinsics for every single thing someone might need to do at comp time, and there's no way to compose these operations either. That said, looking at Zig code, I do find a bit of comp time overuse. For things like printing, I definitely prefer the approach of runtime reflection, since it gives you a simpler interface for looking at a type's properties without including any function coloring. There's also a huge benefit to compiler simplicity when you take the runtime approach. I don't know the full implementation of comp time in Zig, but generally it requires an interpreter inside the compiler, which needs to have proper parity, which is hard to guarantee. Runtime reflection also avoids bloating binary size, since you don't need to duplicate the code for every instance of the type. There's an argument that RTTI bloats binary size, but if you're actually using it, you're almost certainly saving on binary size by avoiding duplicating functions, and if you aren't using it, you can just compile without it. Very useful for things like serialization. Odin's reflection approach is dead simple. Every type that needs reflection info gets thrown into a big hash map by the compiler, which is then exposed by the runtime. Type info of does a basic lookup into the table and gives you all the info you could need about it. It means that in Odin, printf can just be one regular function rather than anything generic, using Odin's anytype, which is a basic combination of a pointer and a type ID. This is less important, but I also think that Zig's approach to variadic args is pretty ugly, and it doesn't really make sense to me that it basically requires generics. Zig has some very magic built-in functions, like @import. It's not a huge deal. Odin has a ton of compiler intrinsics too, but I prefer Odin making certain things keywords that function as their own type of statements. It also prevents you from doing things that don't really make sense, like doing an import inside of a function. There's also a huge amount of built-ins related to casting. I see the idea with it. If a cast does meaningful work or could lose data, you have to be very explicit about it. But I still prefer Odin's approach of having very few implicit casts, even for integer widening and things, with a consistent and simple syntax. Zig is able to parse C headers directly, which sounds nice in theory, but in practice can turn into a big headache in my experience. In Odin, that's not a thing. Bindings are done explicitly and directly, which makes everything easier in the long run. It means you can alias names if you want to, make some bindings private, add overloads, and choose to exclude certain functions from the binding entirely, or even change the types. And that's not to say that bindings have to be done manually. Parsing C headers is relatively simple with the tools that exist, but the approach people take in Odin is to use these tools to parse and then generate explicit bindings, meaning that you get proper Odin code representing the bindings, which you can tinker with in whatever way you'd like. Zig has a first-class build system for your projects written in Zig. This does sound cool, but I don't really see the point. In Odin, you just use the Odin build command, and that covers in most cases. If you do need more, people just write a shell script or a jest file. There's no need to do everything in Odin directly. It's not designed to be a scripting language. Ultimately, the biggest thing that I didn't mention is a basic bias. I started using Odin before Zig, and I've been using it for a lot longer now. They're both fine languages, but in my experience, Odin just feels a lot better to write. It's fun, full-featured, and fast, where Zig feels a lot tighter. I can see why someone would prefer it, and I'm sure it's easier to write correct and safe programs in. I just personally prefer styles similar to what C provides, where Zig steers away from it more than Odin. Also, Zig is trying to be a bit lower level. From some discussions I had in the Zig Discord, it seems more geared towards embedded systems and OS dev, two places where Odin doesn't shine nearly as much. Zig may be the right tool for those jobs, but its systems don't feel very conducive to the game dev and general tools and user-facing software I usually make. Still, I had a lot of fun learning about Zig and talking to some Zig guys for this video. If you want me to compare Odin to more languages like C3, Rust, Nim, or C++, just let me know, and I'm sure I could make a video in the same style. Okay, like, comment, subscribe. Here's my website. Bye.